So if we write everything in terms of x, it means that we replace y by 2400 minus 2x here, right? Then the area becomes this guy. Or we can write everything in terms of y, right? It means that wherever x is, we replace it by 2400 minus y and then divided by 2. Okay? Let us denote this equation is the second one, and this is the equation 3. So now the area in the equation 2, it is a function of x. In the equation 3, it is the function of y. It is simply a variable with different names, right? So it is a function. We want to minimize this area. It means that we are minimizing this function. And how can we find a minimum point of a function? Yes, the first derivative will tell us the increasing and decreasing of it so that we can see where the minimums maybe is. So from the second equation, let us deal with both 2 and 3, right? To understand it clearly. From 2, we take the first derivative. Of the function of the area a of x. And we have that a prime of x, which will be the derivative of x times 2400 minus 2x here. Derivative. So it is a product. You can distribute this product and then take the derivative, or you can use the quotient of the product rule. It's up to you. They will give the same result. Okay? So which way do you like? Sorry? Product rule? Okay, very good. So from the product rule, it will be x prime multiplied with 2400 minus 2x here, and plus, what is it here? Be careful. Let us write it slowly. Derivative of the second terms, right? Now, we do derivative of x give us, what is it, Gary? Yes, very good. 1, 2400 minus 2x here, plus x. How about the derivative of 2400 minus 2x here? Negative 2x, right? So be careful because there is a negative sign right here. Very good. So do you all see it? So it becomes negative right here. Negative 2. Okay. Then if we do this, 1 multiplied with this, it would be simply 2400 minus 2x and then minus 2x again, right? So, or we can write it 2400 minus 4x. Let us write it. 2400 is 4 times 600. Do you agree? Okay. So, what is the like term of these two guys? 4. So we can factor it out. Okay, now we need to solve this equation, right? And this solution, the solution of a prime of x is equal to 0, give us x is 600, right? Then we can make a table of this. The variable x here, it is a length. Therefore, it is always larger or equal to 0. So here. And we don't know how much it would be, but it cannot exceed 2400, right? The maximum of this length is 2400. So do you see it? The maximum. Or you don't have to care about this, or let us just leave it this way, okay? Then the 600 will be at the middle. This is the a prime of x. Let me write it this way. Number 4, this is 600 minus x here at, and number 4 is a positive number. Okay. At 600, this guy will be 0. And from the left-hand side of this, it will be careful. Yeah. If x is 0, then it would be positive, right? And then negative. Wait. Interesting. Okay, let us see. So the product of them give us positive and negative. It is increasing and then decreasing. Oh, makes sense. Therefore, it has a maximum value right here, right? Local maximum. Okay? But now, be careful. It is a function defined in a closed interval from 0 to 2400. So let us consider the boundary value, right? So at the end point, which mean x is equal to 0 and x is 2400. We have that a of 0, it will be what is the area of this when x is equal to 0? Yes. And what is the area of 2400? When x is 2400, y should be 0, yeah. Then it is 0. So at the critical point, a of 600, when x is 600, then it will be 600 multiplied with 2400 minus 2 times 600, right? From the second equation. Therefore, what is the area of this guy? Okay. Therefore, the maximum area would be 7,200 when x is 2,400. Okay, so y will be 1,200. Right, and the area is this one. So is it clear? Sorry? This is y.
Yeah, the area.
And this and the area. Is it 70? I'm sorry, what did you say?
It's isn't it 700?
700. Wait. 6, it is 1,200, right? 2,400 minus 1,200 would be 12. Oh, yeah. I see. I'm sorry. There are 4 numbers, 0. My bad. Okay, very good. Good catch. Thank you, Gregory. Sometimes. Yeah. Very good. Or let us write. It's okay. And feet square, right? Okay, that's it. You can do the similar things with the third equation. Okay, but in that case, you do with y. So, are we good with this one? Right? You okay? Then we can move on to another example. For people on Zoom, is that okay? Okay. Thank you. Now, in the second example, if 1,200 centimeter square of material is available to make a box with a square base and an open top. Find the largest possible volume. Okay. We have the given material. We want to build a box with square base and open top. Find the largest possible volume. Okay, suppose the box is like this one. Okay. Okay. The base is a square. So let us define the length of the square is x, right? You agree? And the top is open. Okay, very good. Then the height is something we don't know. Let us define it. H here. Okay. Now, we know that the materials will be the base and the four sides, right? The top is open. So what is the area of this box? It will be the area of the base, right? And what is it? X squared. And let us consider this side on the right here. What is the area of this guy? H times X, yes. And how about this side? H times X again, right? So there are two H times X. And the front side here? H times X again. And the back here? The same. Therefore, finally, there are 4 times of the side, okay? And let us write the number in front of the variables. So, are you okay with that? About people on Zoom?
Yes.
Very good. So that is the area, and it is given that it is 1200 centimeters square. Okay. What we need to do, okay, from this one, we can write X in terms of H or H in terms of X, right? This is an implicit function, okay? Let us write H in terms of X first. How can we do that? The sum of them is 1200. So we eliminate the variable X, right? So let us write it slowly. Here, X squared plus 4hx is 1200, right? How can we write h in terms of x? Very good. So we eliminate the x squared first, then we divide both sides by 4x. Then we can find the h, which will be this guy, right? Or you can find x in terms of h, but it is a little more complicated. We don't have to. So we know h in terms of x. How about the volume of this guy? What is the volume of this? Very good. The area of the base times the height, which is h here. Okay, very good. The volume is a function of x and h. Furthermore, we know that H, we can write it in terms of x here. Finally, we can write the volume is a function of x, which is v of x. It will be x squared multiplied with 1200 minus x squared divided by 4x here. Okay? So now this is a whole number, x squared, multiply with a fraction. And let us imagine this whole number is a fraction and the denominator is 1, right? So multiplication of this, therefore we can simplify this x here with the x in the denominator. Can we? Do you all see it? The product here. If we write it this way, it's easier to see. Okay? This guy and this guy, when we simplify x, then this guy becomes x here multiplied with 1200 minus x squared and divided by 4. Okay? Write it this way. Now, the same story. In order to find the max and the mean, we need to do the first derivative of the volume. Which is v prime of x, right? The number 4 here, we can write it in front of this. It will be 1 over 4 x times 1200 minus x squared, right? Write it this way. So the derivative of the right-hand side here becomes the derivative of x times 1200 minus x squared. Again, this is a product. So we can use the product rule, or you distribute first. It's up to you. So this time, let us distribute first. Okay, it will be 1200 x minus x cubed. Okay, we do it in many ways. Now the number 1 over 4, we write it. What is the derivative of this guy? Minus 3x squared. Very good. Thank you. Right. Okay, good job. Now 1200. 12 is a multiple of 3. It means that we can factor 3 out. Okay? When we factor 3 out, this becomes 3 over 4. This one becomes 400 minus x squared here. Okay? Very good. Therefore, when we solve it, we solve v prime x is equal to 0. It means that we are solving 400 minus x squared is equal to 0, right? It means we are solving x squared is equal to 400. Okay. And x is a positive number, remember. Therefore, x will be, what is it? Very good, 20. Good job. So we know the value of x is 20. Okay. So let us do the similar things. This is x. The minimum is 0, right? And x is a, suppose the maximum base, it will has, yeah, or let us do this way, do it this way. Okay, the solution here is 20. The maximum of x, the maximum possible volume. This is, okay, let me write it, sorry. Okay, I think it is better if we write it this way. 20 minus x and 20 plus x here, right? And negative 20, 0, 20. And we know that it is always positive. This is our domain from 0. And the number 3/4, it is always positive. We don't care about the value here. Sorry. We don't have to care about negative 20. So let us erase this area. Right? We don't care. Then here is 20x, 20 minus x. Here is 20 plus x. Okay. It is 20 right here. It would be 0. From the left-hand side of this one, is it positive or negative? Yes. And this one is always positive, right? Good job. So therefore, v prime of x in this area at 0, and here it is 0, here is positive, here is negative. So the similar story, it is increasing and decreasing, right? So this has a maximum value right here. Okay. So at x is equal to 20, when x is equal to 20, then h will be this guy, right? Which will be 1/2. Is it right? Let me double check it. $20 square is 400, right? So makes sense. Oh, yeah. The mistake. It is 20. Yeah, just copying and we make mistake. Okay, if it is 20, then it would be 80. Oh, good job. 80, then it will be 100. Very good. Oh, yeah, 10. My bad. Yeah, very bad at calculating this. So at this, the volume of this will be x squared times 8, which will be 20 squared times 10. It will be 4,000, right? Makes sense now. Centimeter cube. Okay. So we have this one. Are we good? Very good. Then do you have any questions? Good job. Then let us play with another example. Find the point on the parabola y squared is equal to 2x that is closest to the point 1, 4. Okay. Now let us look at the parabola y squared is equal to 2x. Then can we write x in terms of y? Right. Remember, normally we write y is x squared and the graph is like this. But now we write it another way around. Therefore, the graph should be so at y is equal to 1, it is 1/2. 1 here, it is 1/2 right here. At y is equal to 2, then it will be 2 squared divided by 2, it is 2 right here, right here. Y is equal to 0, then x is equal to 0. This is not a good graph. But let me see. Y is equal to 2. 2 squared gives us 2. If it is 1, 2 here. One here. 2 here. 2 squared. 2, 2. Well, the graph here, where is it? Okay, let me write it this way. 1 and 2, 1/2, and 1 here. At 1 it is 2. At 1 it is 1/2. At 2 it is 2. Wait. Oh, my bad. Oh, okay, I see. We look at this. I put the wrong one, the wrong numbers. When x is equal to 1, when x is equal to when x is equal to 2, then y is equal to 2. Right here, correct? When x is 1, then y will be square root of 2, which is 1.4 something. It should be somewhere here. Okay, better. Keep thinking about the other way around. Right, 1.4, it is somewhere here and here. Okay. This should be like this. It is y squared is equal to 2x. Okay, just plot it. We substitute some value of x and y. We can draw the graph here. Okay, and the point 1,4, it should be this point here. Wow, 1, 3, 4. It should be somewhere here. It's not a good drop, but you can see it, right? You see this point, point 1 and 4 belong to the graph here. And we find the shortest distance from this point to the parabola here. Okay, that is our task. Now, let me remind you the distance formula. It will be the square root of the distance of 2 points. It would be x1 minus x2 square plus y1 minus y2 square. Okay? Let us call the x1, y1 is the point 1 and 4, right? We're looking for a point that is closest to the one, to the point 1, 4. We don't know what coordinate it is, but let us call it x and y. Okay? Then the distance between these 2 points, what is it? We substitute here, it will be very good, right? We want to minimize the d, okay? But minimizing the d, we will need to do the derivative of this. Then the derivative will get in, the radical sign will get invoked. It is complicated, okay? We do a similar way. Let us consider d squared then it will be 1 minus x squared plus 4 minus y squared, right? If we do it this way, then we minimize d squared. The smallest d squared will also lead to the closest d, okay? But our computation will be easier. So now we have this relation, right? And the point here should be in the parabola. It means that it should satisfy this equation. Do you agree? Therefore, the distance, we can write it in terms of x, or we can write it in terms of y. It's up to us. Okay? Then we can minimize the function with respect to x or with respect to y. But now, in your point of view, which one would be easier for us? Yeah. If we write everything in terms of x, then d, let us call it d squared. Okay? Then d squared here, if we write everything in terms of x, it becomes 1 minus x here, square plus 4 minus y. And y, we need to write it in terms of x, okay? It will be, wow, be careful. If we write in terms of x, then we need to write y in terms of x. It means it will be, and it will be plus and minus here. Square root of 2x, right? There are two possibilities. Do you see it? We need to write y in terms of x here. Okay? Let us write it clearly. If y is positive, then this should be square root of x, right? When x positive. Or minus the negative why don't we just write it clearly? Y squared, then y will be square root of 2x when x is positive, or y will be negative square root of 2x. Is it right? There are two possibilities of y. It would be positive this or negative of the negative things here. It is something complicated right here. Okay. Then it becomes positive of square root of 2 negative of 2x here. But anyway, it is very complicated in terms of x, right? However, if we write this in terms of y, it will be 1 minus x here. It means y squared over 2, right? And then plus 4 minus y squared. It seems that the second choice will lead to an easier equation. So we minimize it in terms of y, right? And let us continue tomorrow. You have a good one. Bye, everyone.